The topic of this video is acids and bases. The essential questions are: what are the strong acids and bases, and how much do strong acids and bases dissociate compared to weak acids and bases? So a strong acid versus a weak acid. Okay, a strong acid, one example of that is hydrochloric acid. And an example of a weak acid is carbonic acid. So a strong acid is going to dissociate completely. What that means is all the H's and the Cl's that are bonded together, because H is a +1 and Cl is a -1, separate when they get into water, as you can see in the picture. Okay, so about 1% of the hydrochloric acid sticks together, and about 99% of it separates. With a carbonic acid or any type of weak acid, it dissociates slightly. So you can see in the picture that a lot of them are still together, okay, and only a few have separated off and released one of the hydrogens. So less than 5% have broken apart or dissociated, and over 95% stick together. So this has a large acid constant, which is called Ka, and that's the acid dissociation constant. And this has a small one because not very much of it dissociates. The smaller the acid dissociation constant, the weaker the acid is. So a couple of other properties that vary between strong and weak acids. Strong acid is going to end up being a good conductor of electricity because it's dissociated so much. Weak acid will still conduct, but they'll probably be poor conductors because they don't dissociate into ions very much, and ions is what allows the electricity to flow. There are 6 strong acids that you'll need to memorize: hydrochloric acid, hydrobromic acid, hydroiodic acid. Then we have nitric acid, sulfuric acid, and perchloric acid. There's no pattern really here. You're just going to have to remember those and commit them to memory. Anything that's not one of those 6 strong acids is considered a weak acid. Here's a couple common ones that you'll come across, but as I said before, anything that's not on that list of 6 will be weak. Hydrofluoric acid is a common weak acid. Acetic acid, like vinegar. Carbonic acid. Phosphoric acid. And nitrous acid. And sulfurous acid. So those are some examples of weak acids, but you don't have to memorize weak acids. You just have to know the 6 strong ones, and anything that's an acid that's not one of the 6 strong ones will be weak. For the bases, it has some similar properties for the strength. A strong base is going to dissociate completely, which means they're going to break apart in water, and they're going to be strong electrolytes. They'll have a large base dissociation constant, and how you remember these, there is a pattern to these. They're hydroxides of the groups 1 and 2. So anything in an alkali metal or an alkaline earth metal combined with OH. So for instance, sodium hydroxide, NaOH, Na is in group 1. Potassium hydroxide, potassium is also in group 1. Calcium hydroxide is in group 2. And barium hydroxide, barium is also in group 2. So you can pick anything on those lists and combine them with OH, and that will be a strong base. Anything else is going to be a weak base. So it's only going to dissociate slightly, just like the weak acids. They're going to be a weak electrolyte. They will conduct, but not very well. They have a small base dissociation constant. We're going to list some common weak bases, but again, if they're not part of the strong bases, they'll be considered weak. So ammonia, ammonium hydroxide, aluminum hydroxide,